Hello everyone, welcome back to our YouTube class the ASTUTE tutelage. So today we are going to solve a series of 100 differentiations, in which today we have to solve 14 out of 100. So here we are given a question to differentiate with respect to x, that is sine inverse a plus b cos x upon b plus a cos x. Here a condition is given that b should be greater than a, right? So let's solve it. Sine inverse a plus b cos x upon b plus a cos x is equal to y. Again putting a plus b cos x upon b plus a cos x is equal to u. Now y will become y is equal to sine inverse u. Here now let's see, you have to find is you have to differentiate y with respect to x, right? So first of all you have to differentiate y with respect to u because it is in the form of u, right? And then multiply. Now you have to differentiate u with respect to x because it's in the form of x. So this is called the chain rule, which I had taught you earlier. So now differentiate y with respect to u. Y with respect to u will be, so here differentiation of y with respect to u, it will be 1 upon root under 1 minus u square. So this is because of formula. Differentiation of sine inverse x with respect to x is equal to 1 upon root under 1 minus x square. So now we have to solve it by putting the value at their own place. So now you have to find differentiation of u with respect to x, right? So differentiation of u, here it is u given, so it has to be differentiated with respect to x. So let's see differentiation of first function, second function as it is. So to get du upon dx, you have to write it as differentiation of first function and second function as it is, which means b plus a cos x as it is, and differentiation of a plus b cos x. Again put it in a bracket. Now first function as it is, differentiation of second function, which is b plus a cos x upon. So I hope you understand it properly. After that we'll solve it. So let's see. So write first function as it is as b plus a cos x into differentiation of a will be 0 minus b sin x, as differentiation of b cos x is minus b sin x, because differentiation of cos x is minus sin x, right? And again now minus, again it will be a plus b cos x as it is, and differentiation of b will be 0 because it is a constant term. And now differentiation of a cos x will be minus a sin x upon differentiation of, again it will become b plus a cos x into minus b sin x minus a plus b cos x into minus a sin x, b plus a cos x whole square. So now what you have to do is just multiply this. So finally you will get, multiply minus b sin x with b, so it will become minus of b square sin x, and again multiply with minus b sin x with a cos x, so it will become minus ab sin x cos x, correct? And minus sign, again multiply minus a sin x with a, so it will become minus a square sin x, and minus a sin x with plus b cos x, so it will become minus ab sin x cos x upon b plus a cos x whole square. Du upon dx will be, so now open all this, so it will become minus b square sin x minus ab sin x cos x Minus and a minus will be plus. So it will become plus a square sin x, and minus will be plus ab sin x cos x upon b plus a cos x whole square. So now these two will get cancelled. So what we left with? We left with minus b square sin x and plus a square sin x. From these two, you can take sin x as common. So what you left with now? A square minus b square, correct? Upon b plus a cos x whole square. And I hope that you understand. And I hope that you all are understanding it. Put the value of dy upon du and du upon dx in equation 1. So what will it be now? So it will be at the place of, so here dy upon dx will be at the place of dy upon du. You can write 1 upon root under 1 minus u square into, at the place of du upon dx you can write a square minus b square into sin x upon b plus a cos x whole square. Now to get dy upon dx, what you have to do is put the value of u here. So finally it will become root under 1 minus, so it will become this. So now again, so now let's understand. Can you write this one as, it was whole square, so can you write this one as, you got this. So now multiply it with 1. So it will become 1 upon under root b plus a cos x whole square minus a plus b cos x whole square upon, it is under root, remember always, b plus a cos x whole square, right? And now here multiply a square minus b square sin x upon b plus a cos x whole square. Here it is in under root, so root will cancel square and it will become, let's see, I'm just doing in this, so you must do on your note copy. So it will become this, square will cancel the root, right? So it will become this. So now in the next step what you will do, that here it is in denominator and it is in denominator of fraction of denominator, so it will become, it will be on the numerator and this one will be denominator. I'm doing this type of thing so that video could not be so long. So here you must have to write it on your notebook properly. If you don't understand, then listen here twice, thrice and many more times so that you can understand it again. So here b plus a cos x will be written. So it will become the numerator, right? So as you have understand that, let's see what rule I had applied here. A upon b upon c is given. Then what you do here? You do a b upon c, which means a upon b and c upon 1, right? So I had did this thing. So in denominator, there, if there is a fraction, then fraction will be turned out like that, right? Let's see, this 1 and this is 2, so it will cancel this and here it will become, this whole square will become, in the next step what it will be, let's see, a square minus b square sin x upon root under b plus a cos x whole square minus a plus b cos x square, right? Here this will cancel out, this will cancel this one, so it will be b plus a cos x, correct? So we had written this as it is. So let's open it. I'm erasing here. What you have to do, you have to explain it in your note copy. So in the next step you will write all these things and you can change here. So it will become b square plus a square cos square x plus 2ab cos x, right? And the next will be minus a square plus b square cos square x plus 2ab cos x, and this all will be under root, right? Again open its minus, so it will become minus, all sign will get changed. So you have to note in your note, copy the next step this, right? So all is under root, so this will be cancelled out because it's the same. And here from these two, what we got in the next step? We got dy upon dx is equals to a square minus b squared sin x upon, here it will be minus b plus b square and minus b square cos square x. From these two terms we can take b square as common, then it will left with 1 minus cos square x, correct? And here it will be from a square cos square x and minus a square, you can take plus a square is common, so it will become minus a square is common, so it will become minus a square common, so it will become 1 plus 1, and from here minus a square get common, so it will become plus will be minus, and it will become cos square x. It will be in under root, and again multiply 1 upon b plus a cos x, correct? Now let's see the next step. So from here your dy upon dx will be a square minus b square sin x upon will be b square, and here we were left with 1 minus cos square x, so 1 minus cos square x will be sin square x, correct? And minus of a square, 1 minus cos square will be sin square x, correct? So I hope you all have remembered the formula given by me. So it will be b plus a cos x, correct? And here finally a square minus b square sin x upon, so let's see, here sin square x will be common, and we left with what? Sin square x get common, and we left with b square minus a square into 1 upon b plus a cos x, right? Again, so here it will become a square minus b square sin x. Here look, sin square x is in multiplication, so it will get out of root, so it will become sin x, and under root we left with root under b square minus a square, right, into 1 upon b plus a cos x. I hope you understand it properly. So again it will become, let's see, sin x will cancel sin x, this will get cancelled, and again here look, we can write it as minus b square minus a square, take minus here common, and under root b square minus a square, which means it has power 1, and you can write it as, square root can be written it as 1 upon 2, like this, 1 upon b plus a cos x. So from here, so it will be cancelled, so because base is same, so you can write b square minus a square 1 minus 1 by 2, that is 1 by 2, right? And 1 by 2 can be written as the root under root of b square minus a square with sign minus upon this one b plus a cos x. So this is your correct answer, and I hope you understand it properly. So stay tuned with this tutelage. So in the next lecture we will do question number 15 out of 100. So let's see you in the next question. Goodbye, take care.